Hello, welcome. A quick one on this. Two ball, I think it's with ball bearings, have volumes to be 1.6 centimeter cube and 5.4 centimeter cube, I think respectively, right? We have to find the ratio of their surface areas, not even the volume. So we need to know what a ball bearing is. It is in the form of a sphere. So the volume of the sphere is provided of the first and the second one. If I want to do record, we know that volume of sphere is 4 on 3 pi r what? Cube. The same way we can also find, okay, let's focus on the volume. Since we are having two ball bearings, their volumes could be volume 1 equals to 4 on 3 pi r cube of the first radius of the first ball. Then let's say we have volume 2 also equals to 4 on 3 pi r cube of what? The second radius. Now here we can take the 1.6 as we are having equals to these values. What can we do? Okay, let me just pick it as a direct ratio. So if I'm going to find their ratio, so that I can find the radius, right? V1 on V2 is going to be this divided by this, where pi will cancel. 3 on 4, 4 on 3 will also cancel, remaining R1 to the power 3 divided by R2 to the power what? 3. Would that be possible? Yes. We are in section A, so let's go. So this is going to be 1.6 divided by 5.4 equals to, these have the same power. So radius 1 divided by radius 2, all raised to the power 3. So right here, we are going to look for this. We need to clear the cube power there. So what do? We can find the cube root of both sides. That will be the only way we can cancel this, but these values individually will become what? Very small. So let's see if we can multiply this by 10. That will be 16. By 10 will be 54. So 16 on 54, common factor 2, 8, 27. So I should be having 8 on 27 representing 1.6 and 5.4. So radius 1, radius 2, all still to the power 3. The power being 3 on the other side means that we can rewrite this as 2 on 3 all raised to the power 3. 2 raised to the power 3, 8. 3 raised to the power 3, that will be 27. So I'm having that equals to radius 1, radius 2, all raised to the power of 3. Since the powers are the same, the bases will also be the same. So that means that from here, I can say that R1 is the numerator here, then R2 is the denominator as what? 3. So I have the values I'm looking for the radius before I can find the surface area. And we know that surface area, okay, let me add the area, is equals to 4 pi r what? Square. So if I'm going to find the ratio, this is A1 divided by A2. I'm trying to conserve space, section A. That will be equals to 4 pi, which will cancel. So I should be having R1 divided by R2 all raised to the power of 2. I don't know if I'm jumping the method that will worry you. It's a step by step. I don't want to show the 4 pi r square divided by 4 pi r square, where the r will be 1 and 2. And they will always cancel the 4 and the pi, leaving the R1 and R2. So if this is the ratio I'm looking for, surface area 1, surface area 2, what is R1? That is 2. What is R2? 3. All raised to the power 2, meaning the first radius is going to be, the first area will be 4. The second area will be what? 9. And if you have question in terms of how I jump some of the steps, you can add that in the comment section. I'm trying to solve this as fast as possible since it's section A, in order not to invite in more concepts. I guess you follow through what we did. Find the radius. That's the first thing we need to find. The radius of both spheres. When we know the radius, we can use it to find the surface area. Then we approach them in terms of our ratio. Like, share, comment, and come back for more.